and then again we can proceed. I'm sharing my window, and also I would like to ensure the visibility of my window as well as the audibility. Yes, my window is visible.
Yes, sir.
Right. Okay. Thank you so much. Uh, Yesterday we have started with the concept called as dimension versus measure. Measure is nothing but it is a dependent variable. It is a numeric in nature, and it's a function of one or more dimensions. Dimension is a independent variable. It is a qualitative in nature or a categorical in nature. Simply, I can say that the measure is a number and the dimension is what we are trying to slice and dice the number by. Then next concept what we have learned is a discrete versus continuous. It's a crucial part in the visualization, have a different impact on it. And the discrete variable has been in Tableau, we are classifying the variable as a discrete continuous. Then the measure may be a discrete or a continuous. The dimension may be a discrete or a continuous. And the color by which the Tableau then again shows whether the variable has been categorized as a discrete or a continuous. Green color indicates it's a continuous. Blue color indicates a discrete. Okay. And the predominantly discrete variable occupies the x-axis. Continuous variable occupies y-axis. Okay. And the discrete variable can be sorted and the continuous variable can't be sorted. These are the basic principles of that particular variable in nature. And I'm showcasing in one example yesterday, the date when that it has been treated as a discrete, then again the first chart. So what is the first chart here I'm showing here? And when it has been treated as a continuous, the order, chronological order that it matters here. So here I can sort based on the alphabets, but here I can't sort then again based on the alphabets. It is not at all possible if it is declared as a continuous. Right. Coming to the scales of measurement, there are 4 scales of measurement: nominal, ordinal, interval, ratio. There are 4 properties: identification and classification, ordering, equal intervals, real origin of 0. All the 4 properties you are saying yes, it is a ratio data. Only the first 3 you can say the data is an interval data. First 2 property only you are saying yes, it is an ordinal data. And if you are having only one property, that is an identification and classification, it is a nominal data. We have seen some of the examples here. One example also I have quoted. And in the roll number, I can't add the first roll number plus second roll number equal to third roll number. I can't say like this. So addition is not possible. Ordering is also in which addition is not possible. First rank plus second rank equal to third rank. I can't say. But the interval data onwards, I can add, subtract. But ratio is not possible with an interval data. But ratio data, any kind of an arithmetic operations you can do. Right. So this is a third concept we have learned. The fourth concept is all about absolute versus relative measure. With a small example we have seen, madam has pointed out rightly. Then again, sir, out of how much marks? Then again, immediately the madam has asked yesterday. But then again, I asked without that, then again, what is your preference? Then again, your preference, what you stated is a ROM. Sorry, Sita. Sorry, exactly ROM. And then again, when I have stated that out of how many marks they have secured, immediately your option has been changed. From that, we concluded that the relative measure is a better. When I started with the second scenario, then again, you picked up the second company, 200% return on investment. But when I'm stating about the absolute figures, the turnover and its a profitability, then again, immediately you stated that the company A is a better. But this scenario 2, then again, makes us to realize that, yes, the relative measure alone may not make a sensible results, but we have to, with the context of both absolute measure as well as the relative measure, we have to read the data and we have to conclude. That is a learning. Right. So for dimension versus measures, the discrete versus continuous, then scales of measurements, and then again these two scenarios, that is a absolute measures and relative measures, the basic concepts we learned. And thereafter we started with the charts construction, so using Excel and the Tableau. And the pie chart I have covered. One dimension is with a multiple level is required, one measure is required. Second, pie chart. Any one of the particular the pie portions can be further made it as a pie chart. Due to this reason, then again one dimension so for the main pie and another dimension for another pie is required. So totally two dimensions with the multiple levels is required for the pie chart, and one measure is required. Then coming to the simple bar chart, again it's a one dimension with the multiple levels and one measure is required. Already I have shown how to construct it. But here what I stated is the structure of the data. We have to aggregate it. So I introduced the concept called as a pivot table to summarize the data or aggregate the data. Raw data, the huge volume of the data, how we can summarize it and how we can prepare it as in a tabular format. From that, how to prepare the graph yesterday I have shown to you. I have shared this PPT as well as this Excel sheet and as well as the Tableau link. I can't share it as a file because that it will be saved in the cloud only. When you are clicking that particular link, that it takes you to that particular website and you can see that particular Tableau workings, entire workings, then again you can see, right? Followed by, I have introduced a cluster bar chart. In that, if you are seeing it in x-axis, one dimension I kept it and another dimension I kept it as a series. In this, the region is in the x-axis, the segment is in the series, and the y-axis, the sales measures that it occupies. And as an extension of that one, I have introduced a stacked bar chart. It's a different kind of a visualization. Same variable I took it, two dimensions. One is a region, another one is a segment, and the region is in x-axis, segment is in series, and in y-axis, I'm keeping the sales as a measure, right? And this is a different kind of a visualization, that's all, right? And this is an absolute measure. When I would like to showcase the relative measure, then 100% stacked bar chart is an appropriate, and in which I am expressing each and every regions, how much percentage has been contributed from the each and every segment. If you are seeing across the region, okay, so the consumer segment contributes nearly 50% of the sales, and the corporate contributes nearly 30%, around 30%, and nearly 20%, 18 to 20% of the sales has been contributed by the home office. So across the region, this is similarity is there. So it's such a kind of a visualizations I can get it. But when I am showcasing the raw data in the Excel, nothing you can't conclude, right? Coming to the next one, line chart. As well as the line chart is concerned, already I stated that it's a time dimension is a matter. So here, one dimension in x-axis, I took it as the date, the dimension in the series, okay, and x-axis dimensions, time and durations, and the one dimensions in x-axis and another dimension in the series. The date dimension is in the x-axis, that it has been treated as a here continuous variable, and another dimension is a segment that is put it in the series, and in y-axis I'm keeping the measure. For this also two dimensions are required and one measure is required. Which one I would like to keep it in x-axis, which one I would like to keep it in the series, depends on our choice, what I would like to project, what I would like to showcase. In this same case, you can keep the segment in the then again x-axis also, and you can make it that particular the years in the where that is a series also. That is also possible. That is also possible. But the line chart is not appropriate. But at the time, the bar chart is more appropriate. Okay, right. Coming to the line chart, yesterday I have shown I can fit the trend line. I can fit the trend line. The equation is there. Right. Now we have to dive into deep in from this line chart with the trend line. So here I'm taking one dimension, that is in x-axis, time dimension. I'm taking it as a continuous variable. And the one measure is there. Yesterday, then again, I stated about the hierarchy. In the hierarchy, time hierarchy, year, half yearly, quarterly, monthly, fortnightly, weekly, daily, hourly. This is called as a time hierarchy. Normally in softwares, the time hierarchy consists of year, quarter, month. Only three. But how much? What I am trying to say is a total hierarchy: year of yearly, quarterly, monthly, fortnightly, weekly, daily, hourly. Such a kind of an hierarchy we can customize on our own. But by default, in any software, the date hierarchy will be year, quarter, month. That's all. Here, I'm taking the quarter level. That is the second level. I'm taking year and quarter, and I'm plotting the sales. Here, there is no series at all. In the series, it's nothing but the sales value I am showcasing. That's all. And I'm fitting the trend line. And in Excel, I can take it just like that. Now, I'm taking you to the Excel now. See, I'm taking the Excel. My Excel sheet is visible. My Excel sheet is visible, sir?
Yes, sir. Yes, sir.
Right, okay. See here. Again, the data structure is important. Without the data structures, if you are constructing nothing, you can't generate. See here, I'm taking this chart, the data, I make it as a one simple workbook. Timing I am taking to here. See here, I will showcase once again, I will construct for your purpose. So in rows, already I stated that the row variable will become x-axis. The column variable will become a series. The body of the table will become y-axis. This is the norms across all software. Whatever may be the software, that may be an Excel, or that may be a Power BI, or a Tableau, or a ClickView, whatever may be the software, this is a norm. Please make a note of it. In the summarized table, the row variable will become x-axis, column variable will become series, and the body of the table or the value area of the table will become y-axis. Right now, I'm taking the order date and I'm putting it in the rows. Please see here, automatically the groups has been created. I'm increasing the size. Now, can you see the size? How it has been created, my dear friends? Actually, this is a raw data. Is it right? The order date is a raw. Is it right? So each and every date I will showcase to you. See here in the actual raw data, when you are seeing it, see this is an order date. I'm showcasing the order date here. See, this is an order date. This is an order date. Okay. And this is an order date. See, each and every order has been recorded. 8/11/2016, 12/6/2016, 11/10/2015. Like the each and every order date has been recorded. But how this particular dates has been grouped based on the hierarchy here. See here, if I'm clicking the plus sign, that it will be expanded as a quarter. If I'm clicking the quarter, the month will be there. If I'm clicking expanding the month, the date will be there. See here, this is automatically will be created. I'm not writing any codes or nothing. In pivot table, this is a fundamental feature. That's all. If any date variable, if you are picking up, see here, once again, I will remove it and I will showcase to you. So here the order date is there. When I'm taking the order date, see here, I will ungroup it and I will showcase to you. See here, this is a raw data. See here, this is a raw data. Okay. When the raw data, when I'm grouping it here, see here, I'm grouping it as a month, quarter, year. See here, automatically that it will be created. Okay. Are you clear now? Right. So this order date is required. Month is not required. I'm removing the month. See, and also I'm expanding all the fields. Okay. Each and every year and each and every quarter. And this row variable will become what? X-axis. Right. Now I'm taking the sales. Sales is the value. Okay. There is a measure, one measure. When I'm taking it, the system counts, but I can change it, the summarization as a sum of the sales. Okay. Each and every year and quarter, what is the sum of sales? And this structure is required to construct a line chart. Now, once if the table is constructed, in the insert menu, I'm taking the line chart, I'm clicking it, see here, beautifully, I can get the line chart here. Okay, I'm reducing the size. 1 minute. So here this is a line chart. Can you see the line chart? Anyone can confirm? Can you see the line chart? Can you see the line chart? Can you see the line chart?
Yes, sir.
Right. Now I'm clicking sum of sales. These are all the filters. I'm hiding this button and see here in this graph, right hand side top corner, the plus sign is there. These are all the options. I can add the access title. I can add the data label. I can add the trend line also. Please see here, I am taking the trend line. And not only the trend line, I'm clicking the trend line. See here, I'm clicking the trend line will be fitted. This is a least square model. This is a least square model. Any type of curve fitting, you can choose it. See here, I'm choosing this line, trend line. I'm double clicking it. See here in the right hand side, I'm getting a pan format trend line. I can take the exponential, I can take the linear, I can take the logarithmic or a polynomial or a power or a moving average or anything I can take it. Normally in the day-to-day life, when we are trying to learn then again prediction models, we are learning the linear model. This is a linear model. Okay, linear model. Okay, right. So after constructing this, then again trend line. Okay, what can I do is I can take then again here the n number of options are there. This is a trend line options, and so n number of options are there. Okay, in this options I can take display the equation on chart. When I am clicking it, the equations will be shown here, and when I'm clicking r square value, the r square value will be also shown. See here, I'm moving that particular object here separately. See in the top, I'm getting it here. This is an exponential one, and this is a normally I can take it's a linear model. Okay, when I'm fitting the linear model, then again I can take it like this. Okay, right. Now, my dear friends, so here the r square is a one value that it will tell how much percentage the trend line exactly explains about the sales movement. Here 0.4272 meaning 42.72 percentage accuracy I can get it, but the accuracy is less actually. For construction purpose we are using it, and then again we are doing such a way. I have constructed this particular graph and I have showcased in this graph. See here the trend line what I'm showcasing, and this then again the PPT, it's such a way I have done it, and the Excel file also I have given to you. You can try your level the best. Okay, right. Are you having any doubt regarding this line chart with the trend line? Here this is a linear model only, it is not a curvilinear model, and equation is there, y equal to 7744x plus 77751. So this is ax plus b. Okay, this is a this is a bx plus a plus bx. So this 7744 is a then again slope, x is a independent variable, and 77751 is a constant, and r square is a 0.3875. 0.3875 is a very least value, and preferably we are expecting 0.6 and above. Then only the trend line what we are calculating, it's more appropriate to predict the future movement of the sales. In this I am stopping, and I am asking the participants whether all the participants got an idea. Any explanation is required. Even in chat you can communicate. Any explanation or any clarification is there as far as this line come trend chart, I will explain it. Otherwise, then again we can move to the next level. Shall we move to the next level?
Yes, sir.
Right, okay. I'm taking to the next level. The next chart is, it's a combo chart. In the combo chart, when you are seeing it, two axes are there. Y-axis, that is a primary axis in which I am taking the sales. Okay, and this right hand side when you are seeing it, there is another y-axis that is called as a secondary axis. The primary axis is the absolute values. In the secondary axis, I am taking the relative values. How many variables are required? Two dimensions are required, two measures are required. Because why two measures? One measure is an absolute measure, another measure is a relative measure. So one dimension in x-axis and another dimensions in the series. That is required. Okay. So one dimension in the x-axis and another dimension in the series, that is required. Okay. So here there are two series, and then again the one series that it occupies sum of sales, another series that it occupies percentage of total sales. Okay. Right. So here this is a combo chart. I am taking you how to construct it. First, you have to understand what kind of a data structure is required. Okay, it's very important. I'm taking the line chart here and see here. This is a combo chart. If you are seeing that the data structure, see here, I'm keeping the order date here. The order date again grouped as month. And again, here it is a discrete variable. I am declaring it as a discrete variable in Tableau. In Excel, there is no such a kind of a declaration of a discrete variable and continuous variable. But Tableau, surely we have to declare it. And in one of the calculations, sum of the sales, another calculation is percentage on total sales. How this 4.13 calculated? The 4.13 percentage calculated by, say here, the January month sales. What is the January month sales? 94,925 divided by, what is the total sales? 2,29,000, sorry, 22,97,201. It's the total sales. Out of this much of a total sales, 94,925 is how much? 4.13 percentage. If I'm converting into, then again 100. If I multiply it by 100, I can get it the percentage here. See here, 14.13. Such a way it has been calculated. Now you can ask a question, sir, have you calculated one by one? No, I have not calculated like this. So I will, once again, I'm taking this, then again chart, I'm data, I'm opening it up in one new workbook. I will showcase to you what I have done it. See here, I'm taking it, I'm now removing, okay, everything from the scratch, I'm preparing it. I'm taking the order date, automatically the group has been created. Quarter is not required, year is not required, and order date is not required. I'm keeping only month. When as soon as I'm putting the order date, hierarchy created, but the remaining variables I have removed it. Now I'm taking the sales and I'm putting it in the value area. See here, value area. There are 4 quadrangles are there, filter, column, rows, values. So this is a value. Again, it's a count of sales. Again, I have to change it to sum of sales. Once again, I'm taking the sales value and I'm putting it here. Again, once again, I'm preparing the sales. Again, I'm converting into sum of sales. See here, sum of sales. After creating a sum of sales in the second column, I'm choosing any one of the value and I'm right clicking it. In this context menu, I'm taking show value as. In that, I'm taking percentage of column total. So each column total will be taken it as an 100%, and the rest of the values are all expressed as a fraction. If you are adding all percentages, that summation is 100%. See here, I have selected it in status bar. If you are seeing it, the total is 100. The total 100, I am getting it here. So in such a way, I created one column for absolute value, another column for a relative value. Once it has been constructed, see here, I'm clicking insert menu. In the insert menu, I have to click charts, all charts. I click combo chart. In the combo chart, see sum of sales, cluster, column, secondary axis. No, it is a primary axis. Sum of sales line chart system by default that it takes. I'm clicking it as a secondary axis. This second variable sales will be shown here as a line chart based on the secondary axis. See here, now the chart is ready. Now the chart is ready. This chart is called as a combo chart. Why it is a combo chart? Because at a time we are handling two measures. Okay, two measures and one dimension in the x-axis and one measure in the y-axis, but there are two series. Sum of sales will become a one series and another series is a percentage of sales is a another series. Here there are two series are there. And the rest of the things, then again, customization of the chart, adding a label, size, width, decimals, all these things are all aesthetic values. So how, because of the raw graph, you will get it like this only. When I have customized it, see here, I have customized this value. I have appropriately given the title, then again access chart, access title, then again legends, percentages I am showcasing it, and the tables I have included. For this, no one necessarily to write the codings, just a logical thought process. What is a variable? Where I have to keep it? What is the structure of the data? It's required to construct the chart, and you have to give it as an argument, and you have to construct the charts. And this is an example of a combo chart. Now I am opening up the floor to raise questions. Any questions or any doubt clarification is required, please ask me. Any doubts?
No, sir.
Right, okay. Showcase Raj sir, in what sense I can take it? Either this extreme or that extreme. Everything is clear is a one extreme and nothing can't be understood is another extreme. Shall I take it in which extreme? In a fun way, I'm asking. Don't take it in a negative sense. Is it okay? My flow is right. Because in a remote, there again locations we are working and we are talking and we are seeing the presentations. So I'm not able to see your face and your facial expression. So
Sir, it's fine, sir.
yeah, right. Okay. Shall I move further? Right. I'm taking you to the next level. And what the next one, then again, I'm proposing is a scatter diagram. For a scatter diagram, my dear friends, see here, two measures are required. The two measures, one measure should be in x-axis and another measure should be in y-axis. That is a primemost condition. The one dimension with the multiple levels is to make it the level of details. Say here, I can say that, then again, the subcategories, copier, paper, accessories, binder, storage, these are all the subcategory, product subcategory. This product subcategory, the dimension, I'm using it. The subcategory is a one dimension, have a multiple levels. Here, n number of levels are there. But in the graph, if you are seeing it in x-axis, I'm taking sales. In y-axis, I'm taking profit. Okay, right. Then these two measures are predominantly required to apply scatter diagram. Without that, then again, I can't apply. But for this scatter diagram, my dear friend, okay, what is required is a different kind of a structure is required in Excel. I will showcase to you, okay, the scatter diagram. With the pivot table, we can't construct. But what I have to do is the consolidated informations in the normal one. I have prepared it. From that, then again, I took it and then again, I constructed. But these are all the hiccups not there in the Tableau. Just like that, then again, I can do it in Tableau. Okay, right. So here, once again, I'm taking it. See what I took it as one column. I take it as a, sorry, here it is not a region. It is a category. Okay, subcategory. This is a subcategory. Subcategory. Even in my shared file also, there is a one. Please, that you have to make a corrections. Please do it. Subcategory. And sum of sales is a one. Then again, measure. And sum of profit is another measure. If I'm selecting this range, okay, or sum of sales and sum of profit, if I'm taking it, see here, and if I'm inserting the diagram, scatter diagram, see here, I'm putting a scatter diagram, I can get it like this only. See here, I can get it like this. From this, I have to go ahead and then again, I have to select the data. Here, especially, I have to add the data. Okay. So what is the data that again I am supposed to add here? Okay, here I can add the labels and appropriately then again I can do it. See here I'm taking it and I'm selecting the select data and these things. Okay, this one then again I can edit sum of profit, and this sum of profit I can edit it, and then again I can say X value, Y value, serious name. This serious name G1 is there. So what can I do is I can take the values here, the copier name and everything. Then again, I can choose it here. Okay. 1 minute. I'm canceling it and I'm coming back here. Okay. So here I would like to cancel it and I have to come back here. 1 minute. Okay. And what I have to do is I have to choose it and then again, or otherwise from here I will choose it, select data. In the select data, please see here. Then again, these are all the then again values, the individual values, sum of profits are there. Okay. And then again I can add. What is the I can add then again the serious name I can add, the x-axis value, y-axis value, all these things then again I can add. Meaning here this can be now or the data can be added. X-axis, categorical axis, what is the values are there, and then again sum of profit is there. Like then again I can add here. In addition to that, then again I can add the subcategory. These subcategories, then again I can feed it here. All the dots see here. If I'm clicking to here, then again you can see the dots, the series can be added here. So now I'm clicking it here. 1 minute. I can showcase to you. So here, this is select the data. If I'm select the data, see here. If I'm selecting the entire data, okay, selecting the entire data. 1 minute. Here, scatter diagram. Okay, and here, this is a add. In the add serious name, then again I can add it. The serious name here. This is a serious name. Okay, if I'm adding it here, then again automatically that it will appear. Once again here, I constructed the graph here, right click it, select the data, and here I can then again click it here. I can edit. Okay, and here the scatter diagram series name is the sum of profit is there, x-axis there, y-axis there. It's okay, fine, well and good. And in addition to that, what I have to do is I have to edit it, and then again I have to give the series name. Automatically that it will appear here. Okay, right. So this is an Excel part of it. Coming to the Tableau, then again I'm opening up a Tableau here. Okay, I will showcase to you how I have constructed it. Tableau also similar to that one, but it's a little bit easy for us. Quickly, then again we can add and then again we can do. Okay, and I'm loading the Tableau. Please wait a minute. Here, MTC Global, or otherwise simply I will take the one Excel file, sample superstore. I will load it quickly. I will demonstrate it. Okay, I have established the connection now. Yesterday I stated that this is a connecting window, and I have connected the Excel file. This is a loading window. I'm loading the order sheet. The records, what we have seen it in the Excel, 9,998. This particular records has been added here now. This is a then again loading sheet. The next is a sheet in which we can create a visuals. Now, what are the two measures? Profit is a one measure. I'm keeping it in the rows. Sales, I'm putting it in the column. As soon as I'm keeping this two measures, automatically the system recognizes with the what? Scatter diagram. This is a scatter diagram. In the scatter diagram, I'm taking subcategory and I'm putting it in the color. Automatically, see here that it has been created. Now, I can increase the size, visibility, entire view. See here that it has been. Now, I can add the subcategory name also. I am now adding it here. You can see here. And what can I do is I can add the profitability. What is the profitability? What is the percentage of sales on total sales? What is the percentage of profit on total profit? Like any kind of calculations, I can bring it and I can add. Simply here, I will showcase to you what is the total profit and what is the total sales. I am showcasing it here. And or the first one, I can say that it's a sales, and another one is a profit here. See each and every data point. Then again, now I can showcase here. This is a scatter diagram with the level of details. It's a scatter diagram with the level of details. Okay. And another one more thing also I have included in my contents. Another one is making the matrix. Here, simply I can see this look, but when I'm adding the average sales, average profit, or median sales, median profit, see here in this line, I can add a reference line. I can add a reference line. In the reference line, simply I'm taking the average. See here, custom. I'm showcasing it here. And the tooltips is automatically, this is an average value. Okay. And this is a custom I'm showcasing here. The custom here, I can say it is a value. I have to say average. Okay. Hyphen the value I am supposed to take it the computations. What is the computation? I will showcase. So the line, I can make it as a little bit darker line. I can take it. This is a reference line. Okay. And this is a black color. I'm taking it. And I'm taking this one. Okay. Black color. I'm taking the black color. Okay. Right. So here, I'm clicking it here. See, the reference line will be created. Above all, above the right hand side, all are above the average value. Below that, it's an average value. Again, I did a mistake here. I'm going back and I'm editing the reference line. So here, what is the required is computations. It is not a computation. It is a value I'm supposed to showcase, or otherwise I can say it is a computation. Computation is there, followed by one space, hyphen space. I have to say value. So what is a computation and what is a value? Computation is an average value. What is the real value that it will showcase? See here in the bottom, when you are seeing it, I'm not able to increase the size, my dear friend. If you are seeing the average value here, the average value is 1,35,129. It's the average sales value. Above which, what are all the subcategories are all false. Copier, accessories, a binder. These are all above average sales. Similarly, for the profit also, I can add the reference line. See here, I'm adding the reference line here. Again, average. And again, it's a custom. And I'm taking the computation. What is a computation? Followed by space, hyphen space. And I'm adding the value here. So automatically the system will show profit hyphen value that it will be shown here. And the line I'm taking it as a little bit. Then again, green color, I'm taking it. Okay, green color. I'm taking the green color line. Then again, I'm doing it. Okay. Green color line. Okay. And the thicker size, then again, I can take it. See here. Now I'm making the average profit, below average profit, above average profit. So 4 quadrangles are there. Now, like a PCG matrix, now I can then again interpret the data. So above sales, above profit. What are all the subcategories are false? Copier, accessories, binder, storage, chair, foam. These are all the categories, subcategories fall above average sales, above profit. These are all the premium products, I can say. Then what is the next one? The opposite diagonal. The opposite diagonal is nothing but below average profit, below average sales. What are all they? Art, appliances, supplies, bookcases, then again fasteners, then labels, envelopes. These are all the things have a lesser sales, below average sales, below profit. These are all the question mark. Like in PCG matrix, how we are making it the same way, ditto, we can do the analysis here. And another one is, as far as the sales is below average, but the profit wise it's a better. It's a paper, it's a one, and another one is an appliances, is another one. Appliances is above 1 and furnishing is below 1. Okay. And another one is sales is better, but profit is below average. That is the machines. And this 4 quadrangles, in which I'm putting the subcategories. Now I'm getting a lot of insight about the subcategories, and I can take the decisions. I can formulate the strategies. In such a way, in Excel, adding is a little bit difficult. Yes, I can do, but lot of working is required. But here, then again, just like that, on the go, then again, I can prepare such a kind of a matrix visualizations in the scatter diagram. Now I'm stopping and I'm opening up the floor for discussion. I'm waiting for your reply. Scatter diagram, in which what I did is I took two measures, profit sales, and what is the level of details, what is the dimension I took it, subcategory. Okay, and what I did it, I add a reference line, above average, below average, that is a reference line. Similarly, profit above profit, below profit, I added. So four quadrangle I have made it. This four quadrangles look like a PCG matrix. What kind of interpretations you are making for a PCG matrix? The same interpretations you can fit it here for the subcategories, and based on this, you can take a strategy. For a premium product, what kind of a pricing strategy, what kind of a promotion strategy, what kind of an advertisement strategy, all these things you have to think of. The products with the above average sales, but the profit is less, what kind of initiative is required? The profit is more, but the average sales is less. Then again, in that, what kind of a thing, again, you have to think of it. So this is all about the strategic decisions. Okay. So this will give a great insight and a great room for the discussion, great flow for the discussion. I'm waiting for the audience to raise questions or clarify the doubts. Yes?
Sir, once again repeat the scatter diagram, sir.
Pardon, sir? Once again, Sudhir, sir?
A scatter diagram.
Yeah, I have opened a scatter diagram. Once again, let us construct.
Yeah.
Yeah, I am taking a new sheet.
Okay.
How many variables are required, sir? As per our
Two.
PPT, let us see. Two measures are required. How many dimension is required? One dimension is with the multiple levels is required. Need not necessarily one dimension, even more than that, but that it may complicate the visualization. So here I'm taking two measures, profit. I'm taking the profit, I'm putting it in the y-axis. That is a row. I'm taking the sales, I'm putting it in the column, that is x-axis. Automatically the tableau constructor bar, that is a scatter diagram. Immediately that it is recognized when I'm giving in two input as a measures. This is only one dot, sum of profit, sum of sales. I have to add the level of details here. The level of details, I'm taking the subcategory. I'm taking the subcategory and I'm putting it in the color. Color is a card that it will make a different color. See here, all my total sales and profit has been sliced by subcategory. See here, can you see the subcategory? Then again, legends, accessories, appliance, art, binder, bookcase. Even the people, those who are not able to see, what they can do is they can click the tableau link what I have given to you. See, like this, I will showcase to you. See here, can you see my, then again, Chrome window? If you are clicking the link, what I have given it as a tableau link, that it will look like this. That it will look like this. Okay. You can see the top, then again, different tabs, pie of pie, bar, cluster bar, like I have prepared it. In that, please see scatter diagram. People can take up and then again they can see. Scatter diagram with the level of details. Here I have added 7% is the profit, 19%, 7% is the total, percentage on sales, percentage on total sales. What is the profit percentage on total profit? That also I have calculated and I have mapped up here. See here, the same one we can work out here. I will work it out. Okay. See here, I have done it here. Right. Now I would like to add the labels. I'm adding the labels for each and every dots. Okay. And here I'm taking the sum of sales and I'm putting it in the label here. I'm adding the label here. See, I will increase the size also for visibility purpose. Okay. So what is the copier? What is the sales? 1,49,528. I'm adding the profit and clicking and dragging into the table. Add the profit also. For each subcategory, I'm adding the profit and sales. Suppose if I would like to calculate the percentage of sales, I can do it and I can add what I did it in my then again workings. I have shown the same one. Then again, I can also do it. Okay, sir. Are you clear now?
Yes.
And in this, I'm adding the reference line. How I'm taking reference line? I'm clicking the sales axis, x-axis. I'm right-clicking it, add a reference line. In the reference line, I'm saying average. Need not necessarily average. You can reference line, you can take it as a minimum or a maximum or a constant or a median. Anyone, then again, you can take. Here I'm taking average. And the label, what that it has to be shown, I'm customizing it. What is a computation? The computation is an average. Space, hyphen space. What is the result I have to show? The value or the profit. And the line, I'm customizing the line. So the green color line with little bit size is increasing size with the thicker size. Okay. See here, I added the reference line. Average is 1,35,129. This is a sales reference line. Similarly, I'm clicking the profit, then again axis, and I'm right clicking it and I'm adding a reference line. Again, here I'm taking the average. Okay. And the I'm customizing the visualizations and the computation. What is a computation? Average is a computation. And what I would like to show the value. What the value, then again, that it has been calculated. See here, the average profit is then again 16,847. See, the above the profit line, it's a above profit. Below that, it's a below profit. Then right hand side of the reference line of sales is a above average. Below that is a below average. Now there are 4 quadrangles. This is a first quadrangle, left hand side. This is a more profit, less sales. The second quadrangle in the right hand side, more profit, more sales. The bottom quadrangle in the right hand side, more sales, less profit. The last quadrangle in the left hand side, bottom, it's a less sales, less profit. Question mark. Normally in PCG matrix, we are learning dog, then again cat, like then again these things, then again we are learning. The same thing, then again you can apply it here. And beautifully, then again you can categorize the subcategory. What all the subcategories are all falls under the premium means copier falls under the premium, accessories, binder, storage, chairs, and phones. In this, then again the top one is a copier, highest profit. Okay. And next to that one is an accessories and phone. Both are similar, but the phone sales contribution is more. Binder, again, it's a higher profit. Storage and chairs are closer, but again, the chairs, the sales value is more. Like then again, lot of insight I can get it from that particular scatter diagram with matrix form. Now I'm coming back to the floor, waiting for your response, queries and everything. In this, you can ask a number of questions. Feel free. I'm taking you to the difficulty level. But one thing always you have to keep it in mind. What is a variable? How many variables? And the location of the variables in that particular graph? And what is the structure of the data? That is a matters as far as Excel is concerned. But in Tableau or Power BI, there is no such a kind of a structure of a data, because in the background, the system will do on its own. But one thing you should be very clear, how many dimensions are required, how many measures are required, whether the dimension and measures should be a discrete or a continuous, whether it is an absolute or a relative. Like all these, then again, knowledge, clarity in your thought process is required to construct a beautiful chart. I'm silent for hearing questions from your end. Any doubts or any clarification is required? Shall we? I'm supposed to rush up because already time now it's closer to 7:50. So I'm taking it to the next level. The next level is here. It's a uh, it's a histogram. For constructing a histogram, my dear friends, the required variable is a measures continuous variable. Measures as a continuous variable. Okay. Bin values calculations. The bin is also required. I will showcase one example, and thereafter then again I will come back to you, so that then again it's very easy for you to understand what do you mean by bin. And it's a, again, simply I can say that it's a frequency table. It is a frequency table. I'm taking you to the Excel file, histogram. See here. Can you see here? I'm taking the quantity. Can you see the consolidated data? Quantity. In the quantity, 1 to 4 quantities, how many orders? 5 to 8 quantities, how many orders? 9 to 12 quantities, how many orders? 13 to 16, how many orders? So this range, 1 to 4, 5 to 8, 9 to 12, 13 to 16. With another example, I can make you to understand mark range. 1 to 10 marks, 11 to 20 marks, 21 to 30 marks. Like we will make a frequency table and we will say how many students are secured or falls under the range 1 to 10 marks, 10 students, 11 to 20 marks, 5 students, 31 to 40 marks, 18 students. Like how we are doing it, same way. This is called as bin. So the frequency is called as a bin here. So what is required for the histogram? Measure is required. That too, the measure is supposed to be continuous. Now you can ask a question. Sir, I'm having a measure, but that is not a continuous. It is a discrete. Am I not able to construct a histogram? Yes, yes, possible. But then again, the histogram is a more appropriate for the continuous variable, that to continuous measure. And that too in x-axis, that too in bin values. The bin values will occupy in the x-axis, and the count, number of candidates fall under the range of 1 to 4. The number of orders fall under the order 1 to 4. Quantity is 6,901. This is called as a counting number of orders. That is in the y-axis. This is all about histogram. Histogram is also looks like a bar chart, but in the bar chart, in the x-axis, categorical variable will come. But here in histogram, the bin value will come. That is a major difference between the histogram and bar chart. Bar chart is for categorical variable, nominal data, dimension. X-axis will be occupied by the dimensions. But in histogram, again, this 1 to 4, 5 to 8, 9 to 12, and 13, 16 is also the bin values are also a grouping variable that it will lies, or frequency or range of values will fall in the x-axis. In the y-axis, the number of candidates, the number of items falls will lies here. Any doubts regarding the histogram, sir? Now I'm taking you to the next level, histogram with the normal chart. Histogram with the normal chart, one example I took it, and here also I'm saying one measure, the bin or frequency in the x-axis, count in the y-axis. But what is an other thing is also required. This first variable required, what I have mentioned, is appropriate for constructing a histogram. But for the curve, normal curve, what is required is the normal distribution value derived from the mean value range within plus or minus 3 sigma is required. For that, I am using a special workbook called as a histogram with the normal. I'm taking the marks. Can you see the marks here? I'm taking the marks here, the raw data here. The marks is there. Okay. And also, 1 minute. And also I calculated the mean value. What is the mean value? Average only. And what is the standard deviation? That also I have calculated. Based on that, then again, I have calculated the norm distribution values here. So this is the range of value. So how I am calculating the range of value is, then again, the mean value. See here, when I'm taking the standard deviation multiplied by 6, meaning from the mean, left hand side 3 sigma, right hand side 3 sigma, put together 6 sigma. So the standard deviation, 6 times of the standard deviation, I took it here. Okay, and that I have calculated here. And this is the interval. I am dividing it to 100. So I am taking it as this is an incremental. So the starting value is here, the mean value minus 3 into standard deviation. Like similarly, afterwards, I'm calculating within incremental intervals. This file also I have shared with you, and the column E is the matters to calculate the normal distribution value for calculations. The another one is a functions with which the normal distribution function with which I calculated the probability value or a normal distribution value. And this one I'm giving it as an input for this file or input for this graph. This orange color, then again curve, so from the F column value. Okay. And I'm not going in detail about this. And Excel little bit difficult, or Excel little bit working is required. But in a Tableau, just like that, there again I can work with histogram. Just drag and drop is more than sufficient for the what, my dear friends, for the histogram, right? And this is actually the normal distribution. I would like to showcase to you the 6 sigma. So the midpoint of the mu, left hand side is a 3 sigma, right hand side is a 3 sigma, minus 1 sigma, minus 2 sigma, minus 3 sigma. The people, those who are comfortable with the statistics, I hope all of you can aware that within 3 sigma range, 99.99% of the data that it lies. Okay. 1 sigma, 68.2% of the data lies, and 2 sigma, 95.4% of the data that it lies, and within 3 sigma, 99.97 or 99.7% of the data that it lies within 3 sigma. This is a logic concept for calculating the normal distribution. This is another example I have showcased to you, and this is a exam anxiety scores for female male, and the bar one is called as an histogram, and the curve is a normal curve, and with the normal curve and then again the histogram, I can read the data. So the first one, the male, as far as the male is concerned, slightly left skewed data. It is not normally distributed, slightly left skewed, because the left skewness is there. See here, the left hand side skewness is there. And for male also slightly left skewed data. So the exam anxiety is exactly not normally distributed, slightly that is a left skewed data. The exam anxiety is more, or the higher values are cluttered in the right hand side. Right. It's all of you are clear about this one? Histogram with the, because the histogram with the normal curve help us what kind of a distribution the data I am holding it. That clearly that it showcases. Okay, raw data, whenever we are having it, we have to first explore the data. Before conducting any statistical test or something, we have to explore the data. For exploring data, different kind of a visualization is a one beautifully that it will say. From the figure itself, we can say that whether it is a normally distributed, not normally distributed, whether it is a left skewed data or a right skewed data, like just like that, the horoscope, how we are trying to predict, the same way with the visualizations, we can predict the nature of the data, right? Shall I move further? Right. I'm taking you to the next level. This is the next chart is a mean chart. The mean plot is a one. The purpose here is to predict the changes in the location between the groups. Here only the location, measure of central tendency. I hope all of you may hear about the word measure of central tendency. That is a location. Average is a measure of central tendency. Mean, median, mode, all are example of a measures of central tendency that talks about location. So the mean plot, it talks about the location among the groups or between the groups. The mean plots are formed by vertical axis group mean Horizontal has its group identifier. I'm taking you to the graph first. Please see the graph. X-axis, I'm taking the months. These are all the data points. Every month I'm taking the value. I'm connecting this, the again data points. The solid horizontal line is the average line. And this is a mean rank. Okay, right. So say for example, first month I'm taking 100 samples. That mean I'm calculating the mean is around 215. Second month I'm taking 100 samples. Imagine the values are around 200 and 208 or something. Like each and every month I'm taking the samples. The samples mean value has been plotted here. The mean of mean, all the 12-month mean has been added and divided by 12, that it gives a grand mean. That is a horizontal line. So this particular line that connected the dotted lines and as well as a horizontal line clearly says the movement. Once again, I'm coming back here. The reference line is plotted at the overall mean. The vertical axis is a group mean. Horizontal axis is a group identifier. The group identifier is nothing but first month, second month, third month, like. What is an interpretation of this particular graph? These are all the questions can be answered by this particular picturization. Are there any shift in the location? Can you say there is a shift in the location? In the first month, what is the location? 215. Second month, 208 something. Third month, 190 something. Fourth month, fifth, sixth, seventh. Seventh month is around 165. Like, is there any shift in the location? Can anyone can say? From the line, from the movement, can you say that comparing the horizontal bar chart, can you say that there is a movement? There is an upward movement or a downward movement? I'm waiting for your response. There is an upward movement or a downward movement?
Downward movement.
Yeah. So, are there any shift in the location? Yes, I can say that yes, there is a shift in the location. What is the magnitude of the shift in the locations? That it can be answered. Is there any distinct pattern in the shifts in the locations? These questions can be answered with the help of this particular diagram. So, what you can answer? There's any shift in the location? Yes. What is the magnitude? Yes, the magnitude is very high. Is there any distinct pattern? Yes, there is a downward shift. Yes, if there is a shift, the magnitude is very high, downward shift. So answer for the question is yes, there is a shift. Yes, the magnitude is very high. Then again, the pattern is a downward pattern. Okay, right. Now I'm coming to the standard deviation plot. This standard deviation plot talks about the dispersion. Okay. So in a vertical axis, I'm taking group standard deviation. In horizontal axis, I'm taking group identifier. The reference line is overall standard deviation. This talks about that particular change in the scale or detect the changes in the scale or dispersion. See, similar way, each and every month I'm taking the samples for 100 samples for which I'm calculating standard deviation. So first month, what is the standard deviation? The first dotted dot is the first month standard deviation, second month standard deviation, like all these things that it has been plotted here. And the horizontal line is a overall standard deviation. Now, from this particular chart, these are the questions then again we can ask. Are there any shift in the variation? What is the magnitude of the shift in the variation? Is there any distinct pattern in the shift in the variations? Now, I'm expecting the participants to answer these three questions. Is there any shift in the variations? Is there any shift in the variations? I'm expecting your answers. I'm waiting for your response. Anyone can come forward. Whether right or wrong, don't bother about it. Please come forward. Please come forward. Is there any shift or not shift? Whether it is, what is the pattern? What is the pattern? Month after month, whether the standard deviation is increasing or decreasing?
Increasing.
Initially increasing, up to which month that it is increasing? Up to 6th month increasing. Thereafter, what happens?
It
After
starts
7 months, it
decreasing.
starts decreasing.
Decreasing. Upon there is a pattern. Okay. And is there any shift in the deviation? Yes, shift in the deviation. What is the magnitude? Again, the magnitude is very high. Okay. So all these three answers can be answered by that particular graphical presentations. So whenever we are talking about the data, first we have to talk about the mean plot. Second one is the standard deviation plot. Any data set, whatever the data you are collecting it, first we have to do it. That it will talk about that particular, the location as well as the variance. And another one more chart is there that is called as a box plot. The box plot is a one that it accommodates both the location and the variation. That is a beautiful chart. Really, I'm recommending all of you to then again little bit put your efforts to understand the box plot. Very, 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 very beautiful tool to talk about that particular data set, what I'm holding it in my hand. That it talks about the location, that it talks about the variation. In x-axis or in vertical axis, we are taking the variables, and the horizontal axis, we are taking the factor of interest. What is the factor of interest? What is the things? Then one example with which I can quote here. But these are all the major components of the box plot. So from the left-hand side, anyone can help me to read. What is the green color? Can you read?
Minimum.
Minimum. Next one is the Q1, lower quartile, median, upper quartile, maximum. This line from minimum to Q1 is called as a whisker. The Q3 to maximum is a whisker. This box is called as an interquartile range, IQR, meaning Q minus 1. Q minus 1 is an interquartile range. Okay. I am exactly fitting this box plot with the normal curve. This is a left skewed curve I am associating with the box plot. What kind of a box plot you will get it? If it is a left skewed data. If it is a symmetric data, what kind of a box plot you will get it? The whisker, the length will be bigger than the box, but the box are equally distributed. Both the whiskers are all equal length. But in the right skewed, see here, the left hand side whisker is a small shortened, and the right hand side whisker is a lengthier or longer, I can say. The box also, it's not exactly divided into two. So the first box, Q1 to Q3 is the distribution is cluttered, and Q2 to Q3, the distribution is scattered. Another one more diagram I will showcase to you so that it will help you to then again read that particular box plot. See the box plot here. Can you see the one diagram? So within 1 sigma, the Q1, Q3 data will fall within 1 sigma. Okay. And the interquartile range. In the previous presentation, I have shown the minimum maximum. Sometimes we will take it minimum maximum as a lower whisker, upper whisker. But exactly I have to take Q1 minus 1.5 times interquartile range is a lower whisker. Q3 plus 1.5 times the interquartile range is a upper whisker. This is exactly that it fits into the normal curve. For Q12, then again lower whisker, it covers a nearly 2 sigma level. Okay, and the Q3 to upper whisker 2 sigma level. Okay, so the box covers 1 sigma, 2 whiskers are covers 2 sigmas, totally 6 sigmas has been covered here. 6 sigma distribution. Read that particular graph patiently. In the presentation time, then again you can't observe everything. Take the presentations, leisurely sit, and then again apply your mind, then again try to grab what is the meaning is all about it, the box plot it is. Okay, I'm coming back here. What kind of a questions then again that it can be answered? Is the factor significant? Factor in the sense, my dear friends, what the dimensions you are interested to study. Okay, and again I will take it here. See here, this is a one meal analysis. Meal in the sense that then again afternoon, the hotels, they are selling meals. One of the particular premium company, we did an analysis. That particular pictorial representations. And the lowest one, black color, is a normal day average sales meals. The red color is a Valarpire Mugurtham average sales box plot. This is a non-Valarpire Mugurtham. Valarpire Mugurtham, non-Valarpire Mugurtham. From these, then again graphs, then again the Mugurtham is the factor. What I am trying to study. Okay. The meal, okay, is the measure. Okay. How many meals that it has been sold out is a measure here. Okay, are you clear? So here, what is the thing? Then again, this is a Valarpire Mugurtham, non-Valarpire Mugurtham, normal day. The day has been classified into three categories. The day is a dimension. There are three levels: Valarpire Mugurtham, non-Valarpire Mugurtham, and average sales. So normally, then again, full moon day, new moon day, like so. Based on that, the marriage they may fix it. They have stated that we are having the different sales. So when you are seeing the normal day average sale, see here, it's normally distributed. It's look like a normal distribution. But when you are taking the Valarpire, this is a right skewed data. And when you are seeing it here, this non-Valarpire Mugurtham, this Valarpire Mugurtham is a left skewed data, non-Valarpire Mugurtham, right skewed data. Right skewed data. See here, this is a one. So the again see here, and this one, the non-Valarpire Mugurtham, this is a right skewed. See here, this is a right skewed data. This is a right skewed data. And this is a left skewed data. That is a Valarpire Mugurtham data. This is a one that's a normally distributed. See here, this is a normally distributed. Okay. And what are the questions that it has been answered? Is the factor significant? Yes. Valarpire Mugurtham, non-Valarpire Mugurtham, and normal day meals, or the number of meals sold is significantly different. I can say, even if you are applying the statistical test, you can get the same kind of results. Does the location differs between the subgroups? Yes, that it differs across the meal. See, when you are seeing it's a Valarpire Mugurtham, non-Valarpire Mugurtham, Q2 is here, 350 meal. But when it's a Valarpire Mugurtham, nearly it's a 800 meal. And when you are seeing the non-Valarpire Mugurtham, then again, this is around, then again, 475 meal. Upper 350, 475, and then again, 775. Obviously, its a location is different. See here, location is different. What is the variations? The variation here, the variation is in the normal day, the variations are minimal. But in the Valarpire Mugurtham, the variations are wide. And non-Valarpire Mugurtham is also wide, and then again, Valarpire Mugurtham is also wide. The sales oscillates wildly, but in a normal day, it's not. The ranges, it oscillates from 250 mil to nearly 440 mil or 430 mil. But as far as a Valarpire Mugurtham, it's a 375 mil to nearly 1000, then again 1080 mils, the oscillations. And when you are taking it here, nearly this is 272, then again 950 mils, that is the oscillation. So does the variation differs between the subgroups? Yes. The Valarpire Mugurtham, Theibare Mugurtham distributions are very high. Location differs. Are there any outliers? Are there? The outliers also, then again, we can say beyond this, then again, whiskers. See, beyond. So the dotted line in this one, when you are seeing the green color dotted line, below the Q1 minus 1.5 interquartile range, that is a lower whisker. Below the lower whisker or above the lower whisker, any data points that it lies, that is called as outliers. That is beyond the 3 sigma point. That outliers also we can trace out with the help of the box plot. Okay, right. So the box plot talks about the location variations, whether the factor is significant or not. And this is one example we have seen. The another example is then again day wise, Monday, Tuesday, Wednesday, Thursday. Now tell me in which day the variation is less. Come on, my dear friends, come on. By seeing this diagram, then again, please tell me in which day the variation is less.
Wednesday.
Wednesday. Wednesday is also high, madam, comparing to Tuesday. Can you say that the Tuesday and Wednesday both are same? Wednesday size is less. Yes. So for Tuesday, then again, variation is less.
Wednesday, there is symmetry we are finding.
Yeah, symmetry, but again, it's not a symmetry. The box is too lengthy. The whisker size are all then again too small. It's not a symmetry actually. The symmetry means, see here, I will showcase to you. The symmetry here, the box supposed to be smaller, the whisker supposed to be a bigger size. That it will take a little bit time, sir, but again, you can read the data. And which one is a right skewed data? Can anyone can say that which day is a right skewed data? Which one is a left skewed data? Right skewed data? Predominantly, all the days are all right skewed data. Is it right? Right skewed data. Okay. Right. I'm taking you to the next example also. And this is an example of the machine. Machine 1, 2, 3. In x-axis, I'm putting machine 1, 2, 3. In y-axis, there is a energy consumption. Okay. In which machine the outliers are more? Can you say that? In which machine outliers are more? By spotting out the fourth machine, it's having a more outliers, meaning the machines that it consumes very least energy as well as very high energy. Okay. And which machine is having a more energy consumption compared to 1, 2, 3, 4? Which energy has a more? And an average, then again, the average consumption is more. Because the y-axis is an energy. Which machine consumes more energy? Average energy is more. Consumption of average energy is more. In which machine?
Third
Three.
machine.
Yeah, third. That's all. It's again common sense. When you are understanding the meaning of that particular whiskers and the lower whisker, upper whisker, and Q1, Q2 interquartile range, each and every data set, whatever may be the volume of the data set, you can put it in a then again box plot. Then again, you can talk about the particular data. See, as far as that particular meal is concerned, nearly then again it's a lakhs to lakhs data set. So nearly 5 years data set with the 365-day data. Okay, 365 into then again 5 years. Imagine how many data points are there, how many records are there. All are consolidated, summarized, and then again we took it as a then again box plot. Now you can ask a question, sir, can we prepare the box plot in Excel? Yes. Can we prepare the box plot in Tableau? Yes. Easily you can prepare the box plot in Excel. Okay, right. Now tell me, I'm opening up the floor for discussion. So far we have covered mean plot, standard deviation plot, and a box and whisker plot. And the last two more charts then again we can cover. The last then again we are in the fag end. Another 10 minutes time is there. Within 10 minutes I will finish up the two more diagrams, and afterwards we can have a discussion regarding this. Any doubts? Mean plot, and then again at least you get a feeler, because within 1.5 hours time, then again what best then again we can do, then again I'm trying my level the best, that's all. But from your side, it's a real effort is required. You have to sit and you have to go through the slides. That is why I have shared with you the workings also. I have shared with you. Please see, and then again get the more insight about each and every construction of graphs. Any doubts regarding this mean plot, standard deviation plot, and then again box and whisker plot? Shall we move further? Right. I'm taking you to the next level. The next one is the dot scale diagram. This dot scale diagram is a very beautiful diagram with the help of an add-in, Excel add-in. There is an add-in called as a Ph.D. Ph.D, the PH Printers Hall. I hope all of you may aware about the Printers Hall publisher. Printers Hall publisher and then again MIT. Both they joined together, they developed a tool called as a Ph.D. The Ph.D is an add-in that it will work in Excel. It's freely downloadable from the websites. Ph.D, if you are typing it as a Ph.D, PH Printers Hall, the publisher name, stat stands for statistics. Okay. Through that, I have constructed the dot scale diagram. All the data points, here the blue colors are all data points. Okay. And the line, the first yellow color line is a 1 sigma. The second horizontal line is a 2 sigma. And another lengthy line, yellow color, is a 3 sigma. And the dark green color is a interquartile range, Q1, and this is a Q2. The red color is a mean, and then again the magenta color is a then again a robber blue is a median value. When it is a normally distributed, the mean and median will coincide. So here the data sets are there. Suppose beyond the 3 sigma, if the data points that it lies, we are called as the outliers. Whenever we are collecting the data set, first we have to look into that one. Is there any outliers are there? We have to first knock off. For example, I can say in a class, normally the average students will be there. Only few students may fail. They may be have the marks of 10 marks, 5 marks, 3 marks, something. Very few students may get a mark of 95, 96, 97. So including these extreme values into my analysis of the class performance, that it will distort. So if these extreme values are beyond 3 sigma, by visualizing, I'm concluding I have to knock off. And after knocking off, I have to take the remaining data set to the analysis purpose. Otherwise, the analysis will be distorted. So whenever you are conducting a research work or whenever you are conducting a day-to-day work, first put it into the dot scale diagram or a box and whisker plot or any tool that's accessible, and please find out whether there is an outliers are there or not. Now you can ask a question, sir, can we identify the data points? Yes, in the box and whisker plot, if you are putting a mouse pointer on the outliers, that it will tell which item or which data point is an outlier. That you can identify and you can knock it off from the source data. Afterwards, you have to start with the analysis purpose so that your analysis will give a meaningful result, or otherwise your results will be distorted. Right. Now I'm coming to the waterfall chart. Before starting into the waterfall chart, now I'm asking a question. Sir, is there any doubt? I'm coming back to the then again meet, and I'm waiting for your query. Are you clear about the dot scale diagram? What is the purpose of it?
Yes, sir.
Right. Now I'm taking you to the next type of a chart called as a waterfall chart. This chart is appropriate for accounting data or any kind of a statements. Here I am taking one example of an income statement. Gross sales, from which I am deducting the excise duty, results in net sales. I am subtracting manufacturing expenditure from the net sales, I am getting a gross profit. I am subtracting operating expenditure from gross profit, I am taking profit before tax. I am subtracting tax, I am getting a net profit. How these type of a data set can be projected in a graph? The best example is a waterfall chart. I'm taking you to the next one. Please see here. Looks like this. What is the gross sales? 1 lakh. Excise duty. Whether the excise duty pull down the gross sales or push up, pull down. How much? 10,000. Afterwards, what is the output results? Net sales. What is the net sales? 90,000. Whether the 90,000 net sales has been pulled down by the manufacturing expenditure or push up, pull down. So minus 40,000. Here that has been shown here. So here, so the 90,000 becomes 50,000. That is called as a gross profit. The gross profit has been pulled down by the operating expenditure 30,000. So resulting figure is a profit before tax. How much that it has been pulled down? Then again, so now the gross sales 1 lakh. How that it becomes a net profit as a 15,000? What are all the pulling factors that it pulls down the total sales into the net profit of 15,000? So the excise duty drops the sales by 10,000, and the manufacturing expenditure pulled down by 40,000, and operating expenditure by 30,000, and 5,000 by tax. Among the thing, which one pulled down more? Manufacturing expenditure. Next to that, operating expenditure. Next to that, excise duty. Next to that, tax. That is an income tax. Like I can visualize and I can say, what are all the increase, what are all the decrease, and then I get total. So the increase is the first gross sales with which I'm starting. I'm landed into the net profit. And this particular chart, I have prepared it in the Excel, and the same workbook I have shared with you also. I have shown to you also. What you can do is you can take this data set, you can try to construct it. See here, choose this one, go to the insert menu, and here there is a chart called as a waterfall chart, and the waterfall chart is there. See here, if you are clicking it, you will get that particular waterfall chart. I have customized everything in a reverse way or that way, and you can get it the same way here. Okay, are you clear now? So construct it and then again get the outputs and then again try to interpret the results. What is the data structure that is required here is such a kind of a data structure. The statement is required for the waterfall chart. Right. And before concluding the session, I would like to say, my dear friends, whenever you are trying to construct a graphical presentation, the first thing is how many dimensions required, whether the dimension should be treated as a continuous or a discrete. What is the all about the measure? Whether the measure is supposed to be a absolute measure or a relative measure. The clarity is supposed to be. Then again, data structure as far as Excel, but Tableau and Power BI, there is no need of bother about the structure. And appropriate charts we are supposed to pick up. Right. With this 2 days session, I tried my level the best to blend the content. What is a basic requirement to start with the visual analytics? So it is a tip of an iceberg. And again, it's a too rudimentary. Okay. Because the visual analytics is an ocean. And again, what I can say is whatever may be the profession, your profession may be HR or marketing or finance or a system or a doctor or a lawyer, whatever may be the profession, now the data are available. How can I visualize the data? How can I derive the meaningful information from that particular data set? For that, the visual analytics is a best tool to get a decision, informed decisions. Okay, the best tool to then again the appropriate decision making in our life, whether that may be a business decision or a personal decision, whatever may be, that will give a great insight for us. With this, I'm opening the session for question and answer because the time is now exactly 8:30. For another 2 to 3 minutes, I'm waiting for the reply. Any kind of a questions you can ask, not necessarily in line with the topics. Then again, related to visual analytics, any kind of a queries you can ask, I will clarify if I am capable of. I am waiting for your questions. Even in chat box, you can type message or even you can switch on the microphone and then again you can say.
No questions on my side, sir. Thank you for such a nice session.
Thank you, Rachana madam. Which extreme end, then again, Rachana madam, can I take it? Either completely understood all.
No, it was, I could understand everything that you explained. It wasn't very difficult to understand.
Okay. But then again, I have shared all the materials leisurely, then I can go through once again or multiple times, ponder over, apply, and then again practice it. Surely, then again, over a period of time, then again you can acquire the skill set.
Yes, sir. That practice will be needed.
Yeah, exactly.
Thank you, sir.
Thank you so much. Thank you so much, Rachana madam. Anybody else? Sudesh sir? For all the other participants?
Session is good, sir, no doubt, but we require at our end a lot of practice for grasping.
Right. Okay. But are you getting a feeler, a bird's eye view about the visual?
Whatever we thought we are getting, but it required a practice.
Right. Okay. One by one, if you are taking it, and then again you can start
so
with the help of the.
Provide all the data or sheets so that.
Yes. I have shared it, and then again share will already share as a shared in the group. Even as soon as then again I have shared it, the next moment then again is share as a shared with the group. From the group, then again you can download all the files, sir. Whatever I have shown to you, then again you can download it and you can use it for a practice. That is why then again I worked out and I have also shared it. Suppose if it is a physical session, then again we can put it in the lab. We can ask you to then again work out. We can guide and then again. But again, it's a time consuming. Time consuming, and again it's a the space that is a location constraints. Location constraints. Anjali madam, Jyoti madam, Michael sir, any comments? Sridharan sir, Shukesh, Raj sir. Right. Please give a feedback about the content. What kind of the future expectations, your future expectations, if you are sharing with sir, sir may come forward to organize such a kind of a workshop also for your benefits. I hope. So, let us